Bismillahirrahmanirrahim. Welcome dear students to the new lecture of histotechniques, the tissue processing part 1. The outlines of today's lecture is first we will discuss about the dehydration of the tissue, that how the tissue can be dehydrated and how water molecule can be removed from the tissue. Second, we will discuss about the different agents which is used for this dehydration purpose and the comparison among the different agents for the process of the dehydration. After that, we will discuss about the second step in the tissue processing, that is the clearing process, how the tissue can be cleared from the dehydrating agent. Then we will discuss about the selection of clearing agent, how a clearing agent can be selected for this process, and we will also discuss the process on which the clearing agent is selected, and in the last we will discuss about the different types of clearing agents, their advantages and their disadvantages. So dehydration, it is the process in which water is removed from the tissues. This process is performed because every tissue contains some amount of free water or unbound water molecules, and the removal of this water or the dehydration of the tissue is necessary for the successful impregnation of paraffin wax into the tissues. So the dehydration should be done gradually from the lower concentration of the dehydration fluid and towards the higher concentration. This gradual dehydration is performed because the difference of the concentration gradient between the tissues, this difference damages the delicate tissues and we cannot get clear image and proper dehydration by putting directly the tissues into higher concentration. So for that why the gradual increase is performed for the dehydration purpose, and smaller the size of the tissue, better is the infiltration of the embedding. Therefore the tissue should be first sliced into thin sections. The optimum thickness of the tissue, it should be kept under 5 mm and 3 to 4 millimeter is a good size for the dehydration. Thin tissues having the size of 2 to 3 millimeter, they needs less time in dehydration, and the tissues which are thicker than the 5 mm, they need more time than the smaller one. So therefore it should be noted that the tissues should be kept in for an optimum type, and it depends on the type of the tissue, the size of the tissue for the in the dehydrating agents. If we give too much time for the dehydration, this may cause the tissue to become harden and become brittle. So the tissue may be damaged, and if we give too little time for the dehydration, that time is insufficient for the removal of free water molecules. For routine sections, the following scheme may be followed. So the first, the tissue is put into 70% alcohol, that is the methylated spirit, and the tissue should be kept in this fixative and in this chemical agent for 1 hour. Then after 70 it is put into 80 or 90% alcohol, that is called the rectified spirit, and these must have 2 changes and each jar have 2 hours time for the removal and for the process of dehydration. After that, a pure or absolute alcohol jar is present, and in that jar 2 changes are there and each jar must contain the tissue for 2 hours. As we have discussed in the previous lecture that the process of tissue fixation is affected by the agitation. So, to help dehydration and to foster this process, agitation of the tissue is performed, and if the agitation is not performed, then this processing may take time more than 2 hours. Or in absolute alcohol, a tissue of size 0.5 to 1 inch thick layer, anhydrous copper sulphate is separated by filter paper, and for this tissues the anhydrous copper sulphate is used. This anhydrous copper sulphate have different advantages. The first one is it increases the lifespan of alcohol. Second, dehydration is betterly performed by using this anhydrous copper, and it is a good indicator to change alcohol. So, that is why anhydrous copper can be used during the process of the dehydration. The different dehydrating agents, the first one is ethanol or ethyl alcohol. This agent is most commonly used and the most popular in different histopathology labs. It is a clear and colorless fluid and it is flammable. This is relatively fast and an efficient dehydrating agent, and ethanol is used for the delicate tissues, and its concentration should be started from 50 to 30% in case of delicate tissues. The methylated spirit or denatured alcohol, this spirit contains 99% of ethanol and 1% methanol or isopropyl alcohol. It is not commonly used. Methanol alone, it is a clear and colorless volatile inflammable liquid. This agent can be used as a substitute of ethanol, but it is less commonly used or rarely used because it is a volatile and it is costly. Therefore, methanol is not used in routine labs. Isopropyl alcohol, this is available as 99.8% isopropyl alcohol and it is miscible with water and liquid paraffin. Isopropyl alcohol is a rapid reacting compound. It is non-toxic dehydrating agent and it do not cause the tissue shrinkage, or the tissue shrinkage in the case of isopropyl alcohol is very minimum. This isopropyl alcohol is a good lipid dissolving solvent. This is the comparison of different dehydrating agents, their advantages and their disadvantages. The ethyl alcohol, it is rapid and efficient dehydrating agent, but it needs license from the government. It is inflammable and it makes the tissue hard and brittle if kept in it for longer time. Methanol is equally effective just like ethanol, but it is volatile and it is costly. Isopropyl alcohol have rapid action, it is non-toxic and causes minimum tissue shrinkage, but it is not possible to use it in the Saladin technique. Dioxone is a rapid acting agent and it do not shrink the tissue, but highly toxic gas is generated in case of dioxone. Ethylene glycol is also a rapid dehydrating agent and it do not require graded solution, and the tissue should be kept in ethylene glycol for longer time, but the reason issue is that this is very expensive and the clearing agent is required in case of ethylene glycol. Acetone may be also used because of its rapid action, it is cheaper and good for fatty tissue processing. The issue with the acetone is that it is quickly evaporate and it is inflammable, and prolonged use may cause shrinkage and brittleness of the tissue. This is the summary of the dehydration, that the different overview and the different points about dehydration for routine laboratory 70, 90 and 100% alcohol each for 2 hours, and the common dehydrating agents are these listed here and they are discussed in the previous slide. Now, the second step is the clearing. It is performed after dehydration and the purpose of the clearing is to remove dehydrating agent for the impregnation of paraffin wax, and the second purpose is to make the tissue clear and to improve the microscopic examination. So, this clearing is performed for the removal of the alcohol. The clearing agent, it should be soluble with the both the dehydrating agent, that is the alcohol, and also the next step of the embedding medium, that is the paraffin wax. So, it is used because the refractive index of the clearing agent should be similar to the tissues. Therefore, it gives clear appearance of the anhydrous tissue, and completely transparent tissue indicate the end point of the clearing process. Now, how this clearing agent can be selected? What are the different factors which affect the clearing agent? The first one is the type of tissue, that the larger tissue it takes more time to clear and the smaller tissue it takes less time. So, the clearing agent should depend upon the type of the tissue, which type of tissue processing is used, either manual or automatic, the conditions during which the processing is performed, that is the temperature, vacuum, the clearing speed of the agent, the speed of removal of dehydrating agent, and the wax replacement, how much a clearing agent can easily replaces the molten wax, and the safety factors, that is the flammability and toxicity, and the last one is the cost. So, these are the factors that affects the clearing process, and the agent is selected on the basis of these points. The properties of the clearing agent. The clearing agent having low melting point is easily and quickly removed by the molten wax, and those agents which have high melting point, they take more time to be removed from the tissue and from the embedding medium. Therefore, the clearing agent with high viscosity have low penetration rate, and the optimum time for clearing is necessary, because if the tissue is exposed to prolonged time, so it may become brittle and more easily breakable. That is why optimum time is necessary for clearing, and the amount of clearing agent should be 40 times about the volume of the tissue, so that it can cover every part of the tissue easily and it is performed in short time. The types of clearing agents, the first one of them is the xylene. It is mostly used clear and flammable liquid, and small pieces are cleared rapidly within 30 to 60 minutes. But the toluene, which is used as a clearing agent, it also has similar properties with like xylene, but the action is slightly slower and it does not harden the tissue if the tissue is prolonged exposed to this chemical. The issue with the toluene is that it is flammable and it is toxic. This is the comparison of the different clearing agent: xylene, toluene, chloroform and esters. These are the routinely used clearing agents. So, xylene shrinks the tissue, it hardens the tissue, it is flammable. It have harmful effect that it is irritant, but less harmful, and it is the cheapest of all. Toluene also causes tissue shrinkage, but it does not harden the tissue if prolonged time. It also have an irritant effect on the body and it is also cheap. Chloroform do not shrink the tissue, do not harden the tissue, and it is not inflammable, but dangerous toxic gases are produced during the heating process, and chloroform is very expensive as compared to xylene and toluene. Ester do not shrinks or hardens the tissue, but it is highly inflammable and it is very costly. It is safest of all these clearing agents. This is the summary of the clearing, that the aims of the clearing is to remove the dehydrating agent and to facilitate impregnation of paraffin wax and to make the tissue clear and improve the microscopic examination. These are the aims. So, the ideal clearing agent must have low viscosity and high penetration rate. It have low melting point. It should be miscible with both the alcohol and the molten wax. It may not damage the tissue and it should be less toxic and less inflammable, as well as cheap. The selection of appropriate clearing agent depends on the type of the tissue, type of processor, processing conditions, for example, the heat, the temperature, vacuum, the safety factors and the cost. The volume of the clearing agent should be 40 times more than the volume of the specimen, and the time during which this clearing process is performed. For smaller tissues, it is performed in 1 hour, and for larger tissue, this clearing is performed in more than 1 hour, and the xylene must contain 2 or 3 changes for better clearing. The end point comes when the tissue becomes completely transparent, and if the tissue is placed in clearing agent for a long time, it may become brittle and friable. So, these are the xylene, toluene, chloroform, amyl nitrate, cedar wood oil and limonene are the clearing agents which is used in the different histopathological labs. That was all for the today's lecture. Hope you have learned about the dehydration and clearing. If you have any question, you can ask in the question box. Thank you. Assalamu alaikum.